All right, number 5 on page 207 gives us the function f of x equals x plus 2 over x minus 3. And it asks us to find the vertical asymptote, horizontal asymptote, and then graph the function. Okay, so let's do vertical asymptote first. We have to find the roots of the denominator. Well, this denominator is pretty simple, x minus 3. We're going to find out where it equals 0. So we solve for x, we add 3 to the other side, and we get x equals 3. Now, as long as that x equals 3 doesn't also make the numerator 0, right? If it did make the numerator 0, we would have a hole, but it doesn't because 3 plus 2 is 5. So this is our vertical asymptote. I'll just label it VA. Now we can find the horizontal asymptote, which is the 3 cases, right? And we know that in case number 2, if the degrees of the numerator and denominator are equal, the horizontal asymptote is y equals a over b, where a and b are the leading coefficients of the numerator and denominator, right? So we can see the degree here is 1, and the degree here is 1. So those degrees are equal, so it applies to case number 2. Now the leading coefficient here is a 1, and here it's a 1. So for the horizontal asymptote, we're going to have y equals a over b, and both a and b equal 1, which is just 1. So the horizontal asymptote is the equation y equals 1. Now we're ready to graph. Plot my vertical asymptote at x equals 3. My horizontal asymptote at y equals 1. And now I can draw in the graph. Now, the way that we draw in the graph is we have to actually pick some x values and sort of plot some points here. I'm going to start with some x values bigger than 3. So let's plug in 4. 4 plus 2 on top would be 6. 4 minus 3 would be 1. So I have the point 4, 6, which would be way up here. All right, how about 5? So plug in 5 for x. I get 7 over 2, which is 3.5. So that's coming down a little bit. Let's plug in 6. 6 plus 2 is 8. 6 minus 3 is 3. 8 thirds is, what, 2 2/3, or like 2.6, 2.7. So we go 3, 4, 5, 6, and then 2 2/3, so something like this. So we can see that our curve is starting up high, and then it's coming down. We don't necessarily have to be exact here. I'm running out of Smartboard a little bit, but we're going to have that type of curve. Now let's pick some x values less than 3. So let's do 2. X equals 2. Plug it in, I get 4 over negative 1, so negative 4. So I have 2, and then negative 4 would be down here. Let's plug in 1. 1 plus 2 is 3. 1 minus 3 is negative 2. So that's negative 1 1/2. So negative 1 1/2 would be something like this. Let's just plug in 0 since that's easy enough. Negative 2/3. So we'd be about right here. So we can see that our curve is starting to come, oh, sorry. I have to go all the way up to the asymptote, right? It's going to come sort of like this, and it's going to keep going like this. So next is number 6 on page 207. Same type of problem. different rational function. F of x equals x minus 1 over 2x plus 1. So same thing, we have to find the asymptotes and then graph it, right? So let's take the denominator, set it equal to 0, find the roots. Subtract 1 to the other side, and then divide both sides by 2. X equals negative 1/2. So that's going to be our vertical asymptote. Make sure that that x value of negative 1/2 doesn't also make the numerator 0. If it does, we know it's a whole. In this case, it does not, so we're good. Now we have to find the horizontal asymptote. Look at the degrees, 1, 1. So that case 2 applies again. Now our leading coefficients are 1 and 2. So our horizontal asymptote is going to be y equals 1/2. Now we're ready to graph it. Plot my vertical asymptote at x equals negative 1/2. And my horizontal asymptote at y equals 1/2. Now start to plot some points. Plug in, well, let's plug in 0 for x. So up top, we get negative 1. On the bottom, we get positive 1. So I have the point 0, negative 1, which is, I'm going to use a different color here, which is right there. Let's plug in positive 1. So I get 1 minus 1, which is 0. So I'm going to get the point 1, 0. Let's plug in positive 2. 2 times 1 is 2. 2 minus 1 is 1. 2 times 2 is 4. 4 plus 1 is 5. 1/5. So I get 2, 1/5. So that's going to be slightly above there. We can see what's starting to happen here. Our curve is going just like that. Let's plug in some x values less than negative 1/2. So let's plug in negative 1. Negative 1 minus 1 is negative 2. 2 times negative 1 is negative 2. Plus 1 is negative 1. So I get positive 2. So I have the point negative 1, positive 2 right there. Let's plug in negative 2. 1 times negative 2 is negative 2. Minus 1 would be negative 3. 2 times negative 2 is negative 4. Plus 1 is negative 3. So that's 1. So now I have the point negative 2, 1. So it looks like what's going to happen here, since I sort of saw this curve already over here, I know that the other part is going to kind of curve the opposite direction, and I'm just getting some of the points to see how that's going to happen. So I can draw that in, and now I have the graph. All right, we're looking at number 8 on page 208. They give us the function f of x equals ax squared plus bx plus c. We've seen this before, standard form of a quadratic, right? Over dx squared plus ex plus f. Okay, also standard form of a quadratic. And they're asking us, what is the horizontal asymptote? Okay, so I like this problem because it probably throws everybody off. you probably get a little bit intimidated by the fact that you have A, B, C, D, E, F. I wouldn't be surprised if you really don't know what to do with those things. But just focus on what they're asking you. They're asking you for the horizontal asymptote, right? Well, remember, we have these three cases. So which case does this fall under? Well, let's take a look at the degrees. Second degree, second degree. The degrees are equal, right? So that's case 2 again. So the horizontal asymptote is y equals a over b, where a and b are the leading coefficients. Well, the leading coefficients are a and d. So the horizontal asymptote is going to be y equals a over d. All right, so we're looking at number 9 here. It says Juanita is trying to determine the vertical and horizontal asymptotes for the graph of the function f of x. You can see the function there. Describe and correct the error Juanita made in determining the vertical and horizontal asymptotes. So first we better look at her work and figure out what she's doing. Right? This is the original function f of x. She has factored the numerator and the denominator. And we should be able to recognize this because we learned factoring. Right? The numerator factors into x plus 4 times x minus 1. If we FOILed those back together, we would get x squared plus 3x minus 4. She factored the denominator into x plus 3 times x minus 4. If we FOILed those back together, we get x squared minus x minus 12. And now she says that the vertical asymptotes occur at x equals negative 3 and x equals 4. Well, we like this because we know the rule for the vertical asymptotes is that they are the roots of the denominator. So she took her factors in the denominator, the x plus 3 and the x minus 4, and she set each one equal to 0, and then she solved it. X equals negative 3, x equals positive 4. And that's where she got the vertical asymptotes right there. So we like that. No problem there for Juanita. Now we look at the horizontal asymptotes, and she says y equals negative 4 and y equals positive 1. Well, looking closely at that, she tried to do the same thing for the horizontal asymptotes as she did for the vertical asymptotes, except she tried to do it to the numerator. She found the roots of the numerator and thought those would be the horizontal asymptotes. But we know that's not how we find horizontal asymptote. Horizontal asymptotes come from the three different cases, right? So Juanita needs to choose which case her function falls under and then apply that rule. So look at the degrees, 2 and 2. They're equal. So this is case 2 again, right? So y equals a over b. So the leading coefficients of the numerator are a 1 and the denominator a 1. So this horizontal asymptote should be at y equals 1 over 1, or just 1. Y equals 1.